Oh, so it's that time already? Hope you enjoyed your Easter. I'm working on enjoying mine right now. Anyway, hey, welcome to class. Geometry. We are getting close to the end of this unit. We're lesson 14 today. We've got like 3 or 4 or 5 lessons left, and then we'll be looking at a unit test before we move on to our new material. So let's see. What have we got today? Get all set up here. Okay. Hey, what do we got there? That looks pretty good. Make sure it's focused. All right, which one doesn't belong? Coordinate proofs. I'm not going to spend a lot of time on that. We can always remember this is one of those where there's no wrong answer. We can, ooh, it did not detect it. I am blurry. Hey, there we go. So remember, there can be lots of correct answers on that. If you can justify it, I'm not going to spend a lot of time on that. We don't want to use up a lot of video time on something that has no wrong answer. So let's do this. Name this quadrilateral. Okay, let's pull this up here. Got that. I'm going to bring it down just a little bit, just a little closer in here. All right, so a quadrilateral, and we don't have a drawing of it on this problem, has the vertices 0, 0, 4, 3, 13, -9, and 9, -12. And wants to know what type of quadrilateral is this? Well, they don't give us a graph, so we're not supposed to graph this. We're supposed to be able to determine. So here's what we'll do. Let's give them a name. This would be A, B, C, D. Okay. So let's find the slope from A to B, all right, and then compare that to the slope from B to C. That'll tell us something. It'll tell us at what angle those lines meet. That might help us. So A to B. Remember, to find the slope is the difference in the y's over the difference in the x. It's written as a fraction. So let's go from the second one to the first one and subtract. The y's go from 3 to 0. So 3 minus 0. This is A to B. And 4 minus 0. So the slope is 3/4 from A to B. That's the slope of our line. Chocolatey. B to C. Let's find out what our slope is from B to C. So if we look at the second point, subtracting the first point, the y's, -9 minus 3. And 13 minus 4. -9 minus 3. What is that? That is -12. And 13 minus 4 is 9. Okay, so we got -12/9. Pardon me. Let me simplify that. So if we take 3 over 3 and we divide it into that, we can simplify this down to -4/3. Ah, very good. That tells us a lot. If the slope of this one is 3/4 and this one's -4/3, those are opposite reciprocals. One's positive, one's negative. One's 3/4, the other one's 4/3. Opposite reciprocals. 90-degree angle. That corner is at a 90-degree angle. So let's check the next corner. BC and CD. We got BC. Let's go look at CD. -12 minus 9. 9 minus 13. Sorry about that. -12 minus a -9. Wait a minute. That's different. I had the wrong thing in there. -12 minus -9. Well, when we subtract a negative, that's the same as adding, right? So -12 plus 9. So that would be -3. 9 minus 13 is -4. -3 over -4. That's a negative divided by a negative. So that's a positive 3/4. Hey, this is the same slope as this one. So those are parallel to one another. And these are opposite reciprocals. So that is also at a 90-degree angle. So what we found out is we have a 90-degree angle, and then it goes down and has another 90-degree angle, and these are parallel. And since those are parallel and 90-degree angles, this one has to be also 90-degree angle. So that has to also be parallel. So this is a rectangle. It's a rectangle. Has to be a rectangle. 2 sets of parallel sides, and it is 90-degree angles. It's a rectangle, which is also a parallelogram. A rectangle is a parallelogram. We don't know if it's a square because we don't know if all the sides are the same length. We just know that they're 90-degree angles. Okay. 4 90-degree angles, rectangle. Find the perimeter. Okay, now we're going to need some length, right? So we need to know how far it is from 0, 0 to 4, 3. And then we'll need to know how far it is from 4, 3 to 13, 9. And then we'll see, since those are, it's a rectangle, we don't have to find the length of the other 2 sides because they have to be the same. So let's find those first 2. So from 0, 0 to 4, 3, let's think about that. If it goes from 0, 0 to 4, 3, all right, this is 4, 3, this is 0, 0. We can find that length using a right triangle. If we took this straight over to where it was right underneath that, that would be at 4, 0, right? Because this is the point 4. So that'd be a 4, 0. And then go straight up, we can make a right triangle and use the Pythagorean theorem. Right? So the length of this side of our right triangle from 0, 0 to 4, 0, we know that is 4. And then from 4, 0 to 4, 3, we know that that goes up 3. So we've got a right triangle that has a side of 4 and a side of 3. So 4 squared plus 3 squared. So this is always, the hypotenuse is always c in your a squared plus b squared equals c squared. Equals c squared. 16, 4 times 4 is 16. 3 times 3 is 9. 16 plus 9 is 25. C squared is 25. So if c squared is 25, what number do you multiply by itself to get 25? Well, there's 5 and negative 5. Remember, there's 2 different numbers that we can get 25 by multiplying by itself. But since this is a length, we're throwing out the negative. We can't have a negative length. So this must be a length of 5. Great. So that would be AB. This is a length of 5. I'll write it up there. This is a length of 5. So that means this is also a length of 5. All right, so let's find how long that the BC is here. All right, try not to have too much of a shadow on our page. May have created more of a shadow. So BC goes from 4, 3 to 13, negative 9. So 4, 3 is 1 point, all right, and 13 would be farther this way, but negative 9, so it would go down to 13, negative 9. So we know going from here to here, it would go over as far as the 13. So now it would be at 13, 3. If we just went straight across, we're not going up or down, we're keeping the y at 3, but we're taking the x all the way from the 4 and moving it all the way over to the 13, so that way it lines up. And then we'll go straight down from 3 to negative 9. So we need to find this side of that right triangle. Okay, so how far did we go from 4 to 13? Well, that added a distance of 9. And how far did we go from 3 to negative 9, which means we crossed the x-axis here somewhere, right? We were a positive 3, now it went to negative 9. So it went down 3 to the x-axis, and then it went 9 more to get to negative 9. So this is a length of 12 on that side of the triangle. So figuring out how long our line is, remember this is the point B, this is the point C. Trying to figure out how long BC is. 81 is 9 squared. 9 squared plus 12 squared. 12 squared is 144, will equal c squared. So c squared equals, what is 81 plus 144? That's 225 equals c squared. So what number multiplies by itself to be 225? Well, it ends in a 5. So it's got to have a 5 in the answer, because there's not another number that would get us to a 5 unless it has a 5. And since we're doing the same number times itself, 15 works. 15 times 15 is 225. Negative 15 also, but this is a length, so we're going to throw that answer out. So this is a length of 15. So that tells us that this is 15 and this is 15. So finding the perimeter, 15 plus 5 plus 15 plus 5, 40. Perimeter is just the distance around. If we walked around something, how far would you walk to go around it? 5, 15, 5, 15. Perimeter. All right, find the area. What's the area of a rectangle? Length times width, right? So the area would be 5 times the 15. That is the length and the width. 15 and the 5. So that is 75 is our area there. 75. All right, so we can do a lot with it without having the graph. Now, I actually do have the graph of that because I wanted to just show you there are the 4 points. And if we connected those, do I have the ruler in here? I don't know where my ruler ran off to. Let's do it anyway. All right, so if we connect those, ooh, that's a long one there. Try to get that straight. That's pretty good. Oh, not bad for freehanding it there. Yeah, we can see that's a rectangle. That's a rectangle. And the length is, this is the length of 5, and this is the length of 15, which we could calculate again by making that right triangle. Let's see, it goes from there straight over to there. 1, 2, 3, 4, 5, 6, 7, 8, 9. See, that's a 9 that we figured out without the graph. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See, that gets us our 9, 12 right triangle that we had earlier. And, same thing on this. This is 4, and that's 3 to figure out the 5. So if you need to get some graph paper, print some off, you can just go on the internet and search graph paper, and you'll find printable graph paper that you can print out if you have a printer. Or you could just kind of make your own if you need to. But we should be able to do it without it, as I did on this paper. Just kind of creating the points, saying how far from 0, 0 to 4, 0. Well, the X just changes 4. Trying to keep it straight, trying to keep it level. So we can do that. We can learn a lot just having the points. Just having the points. All right, we're going to do one other thing today. So not a real long lesson, trying to keep this short. Here's an image of a circle with several points. And you can see there's a point there, a point there, there's a point there, there, and we have those same points marked at the bottom of the circle. Okay? This is an interesting activity. We're going to learn a lot about circles and what we call inscribed angles. That's taking an angle and putting it in a circle to where all the vertices, all the points of the triangle are touching the circle. So that would make it an inscribed. All right, so let's ask us some questions here. What kind of segment is BC in reference to the circle? Let me raise this up because we got a lot of questions and we need to refer back up to this diagram all the time. So give us some room to see everything. All right, so what kind of segment is BC? Well, B is from here to here. What kind of segment is that? It goes through the center of the circle. It goes from one edge of the circle to the other edge. That makes it a diameter. That is a diameter of the circle. All right, we can see that. Now choose one of the plotted points in the circle. We'll call it D. All right, you are D. We're just going to choose one. We've chose it. We have named it D. It has a name. Draw segments BD. Okay, so now we got to draw. Oh, and I'm going to wish I had that ruler. BD. And segments DC. Oh, got to do this long one over here. All right, let's see if we can keep this straight. Oh, I'm doing well today, doing well today. All right, we have connected BD and DC. What kind of measure of that angle does that appear? This angle right here, what does it look like that is? Well, let's see. Let's turn it to where we see it like that. Boy, it looks a lot like a 90-degree angle, doesn't it? I'm just gonna kind of mark that kind of a 90. It looks like a 90-degree angle. Calculate the slopes. Okay, that'll tell us for sure if it's a 90-degree angle, right? Because if it's 90 degrees, it means those lines are perpendicular to one another. That would be a 90-degree angle, perpendicular, which means their slopes would be opposite reciprocals. One be positive, one be negative, and the fraction would be turned upside down. So let's calculate those slopes, and we'll learn a lot here. All right, so from B to D, we have a graph, so slope is easy. We just count the rise over the run, right? Rise over run when we have a graph. It goes up from 0, it goes to 1, 2, 3, 4. D is on 4. So our slope of BD is 4 over, and let's see what our run is. It goes from -5, goes 1, 2. That gives us the run. So it went up 4 and over 2. So what is that? 4, 2. We can simplify that. 4 over 2. 4 divided by 2. That is just a slope of 2. Right? That's a slope of 2. So that is the slope from B to D. So what is the slope from D to C? Okay, the rise. The rise, it goes down. All right, from D it goes 1, 2, 3, 4. So DC has a -4 rise. And then how far does that run? Goes from -3, goes 1, 2, 3, 4, 5, 6, 7, 8. -4/8, which we can simplify again, right? We can divide by 4, divide by 4. 4 over 4, which is divided by 1. So that would be -1/2. 2, -1/2. Are those opposite reciprocals? 2 is the same thing, remember, as 2 over 1. We don't ever write the over 1, but all whole numbers are over 1 if we wrote them as a fraction. So if we take 2 and we turn it upside down, it is 1/2. And this is positive, this is negative. These are opposite reciprocals. What do the results tell us? Perpendicular. That's what they tell us. Perpendicular and 90 degrees. It is a right angle. So when we took B to C, which is a diameter, we took this point here. It absolutely is a right triangle. That's pretty cool. Compare it to a different point. Okay, maybe we just got lucky. We picked the point that happened to be a right triangle. Let's pick another one. Well, let's not do that one to be the same one kind of reversed, right? So let's pick either this one. Let's go over here so it doesn't kind of get in the same area. But this would be a lower. Oh, we can even pick one down here. Let's pick the one that's down here. How about that point? So we'll go from C, and we'll call this one E. And then we'll do this all the way across to E. Alright, so we've got this angle down here. It's not going to make a rectangle because if I'd have chose this, it should have been a perfect rectangle, right? Because I chose a different point intentionally, but I want to see what this angle is. What is this angle? So let's look at our slope from B to E. So BE is, what's it rise? It goes 1, 2, 3. 3 would be how far down it went. So it went -3. It went down. The rise actually dropped. So it's a -3. And then going from B, 1, 2, 3, 4, 5, 6, 7, 8, 9. -3/9, which would be the same thing as -1/3. All right. 3/9 simplifies to 1/3. So it's a -1/3 slope. How about this one, E to C? So let's look at E to C. I'm going left to right. The rise goes up 1, up 2, up 3. The run is 1, 3 over 1, or 3. Ooh, again, opposite reciprocals. One's positive, one's negative. We have 3, 1/3. Same. 90 degrees. So this is also a 90-degree angle. This would not be a 90-degree angle. So don't let that confuse you. And this would not be a 90-degree angle. Just because we changed the point. Like I said, if we went to this one, that would have completed it the perfect. But this one is shorter than that one. So it's not creating it. This is not these two. Those two are not. Okay, so what conjecture can we make that captures what we're seeing? What we're seeing is if we have a diameter, okay, we have a diameter, and we pick any point on the circle, that's what we're seeing. We just picked any 2 points. We didn't, we could have picked this one right in the middle. We could do the point from there to there and there to there. And what do we expect? From what we're seeing, we expect that would also be a right triangle, right? We think that would also be a right triangle. When we turned and looked at that, that would be a right triangle. If you pick any point on the circle and connect it to the 2 ends of a diameter, it creates a right triangle. That's our conjecture. That's what we're seeing. A right triangle, when you have a triangle that's inscribed in a circle, which means all points of the triangle are on the circle. When you have that happen, it's going to be a right triangle if 2 of the points are on the diameter. Right? On the diameter. It's not going to happen if we chose from, let's say, here to here and a point. Right? None of that even looks like a right triangle. That's a lot bigger. That's a lot smaller. It has to be connected to a diameter. But we could have chosen this as our diameter because those points are opposite each other. So we could go from there to there and choose another point. That point to there would make a right angle. Any other points, as long as it's a diameter. We just chose the easiest one to see across there. So, triangles connected to a diameter and any point on the circle make a 90-degree angle. Pretty cool thing. Pretty cool thing. All right, that is the lesson today. But I want to show you what your assignment's going to look like because I have that right here printed out. Let's go through that real quick so you have some idea what you're doing when you get there. The first problem is similar to the first one I did. You have a quadrilateral that has these vertices. So without graphing it, just tell me, what do you need to do to prove it's a parallelogram? Right? We proved it's a parallelogram. Ours was a rectangle, specifically. What do you need to do to prove it's parallel? And a parallelogram, remember, has 2 sets of sides that are the same length and the same slope. Okay? Parallelogram. Parallelogram does not have to have 90-degree angles necessarily, but it would have the same length sides. So you're telling me, what do you need to do to prove that? Which just gave you really big hints right there. All right, this says a rhombus. Remember, a square is a rhombus, but a rhombus does not have to have 90 degrees. It could be tilted, but it would be all 4 sides the same length. All right, so a rhombus has the vertices at 0, 0, 5, 0, 3, 4, and 8, 4. Find the slopes of the 2 diagonals. Oh, the diagonals. If we name these A, B, C, and D, a diagonal would go from A to C and B to D. Diagonals would not go from 2 points that are next to each other because that is a side of the rhombus. So you're finding the slope from A to C, and you're finding the slope from B to D, as I label them there. Okay? A to C, B to D. And you can go back and back up the video and see how I found those slopes on the points on the first problem. And what do the slopes tell you about the diagonals? Right? So you're looking to see, are they opposite reciprocals? Are they parallel? What are they? Neither. Right? So see what the slopes are and see what that tells you. And finally, your last problem. 3 problems today. What must be true if the triangle formed with these vertices? Here's your 3 vertices of a triangle, not a 4-sided triangle. This is a triangle. If it's a right triangle, what has to be true? Okay, again, you're just telling me. You don't have to do the math. You can do the work and put that if that helps you explain it. But I'm just asking, what must be true? Okay, so just tell me what has to be true. You don't have to write a whole book. Just write enough for me to know that you understand what would have to be true if that is a right triangle. All right, and that's it. So these 3 problems, hopefully that's not taking up a lot of your day. I'm trying to keep these lessons down to a reasonable amount of time. Sure, there's some work, but I generally have you an hour and a half in class, and then if you have homework, it's beyond that. So I certainly don't want to take up an hour and a half of your day or any more than that maximum. So, and we're only having 2 lessons a week. Do work you can be proud of. We'll see you next time.